This is the corporate headquarters of Midtronics Incorporated in Willowbrook, Illinois, USA. Midtronics is a technology-driven corporation that has established international leadership in the development and marketing of battery management products. The products researched, developed, and manufactured here have positioned the company as a leader in the industries it serves, the transportation, power, and military sectors. In the process of establishing international leadership, the company has accumulated more than its share of patents, over 100 and climbing. Midtronics' presence is global, with offices in IJsselstein, the Netherlands, North Bay, Ontario, and Canada, Shenzhen, China, and a worldwide network of distributors. Midtronics conductance testers and diagnostic chargers are the industry standard for battery warranty decisions at automotive dealerships, battery retailers, and service centers worldwide. We will now focus on a unique benefit that Midtronics industrial test equipment provides to the communications and power industries. Where an uninterrupted power supply is absolutely essential, Midtronics has developed the preferred and patented technology for battery management. Utilizing handheld conductance measurement devices, a battery's state of health can be determined quickly, efficiently, and reliably wherever required. Let's take a closer look at this handheld technology in action. The features and functions of any Midtronics analyzer make it ideal for stationary battery management where reliable backup power is absolutely critical. The analyzer is a microprocessor-based tool designed to perform conductance tests of any 2-volt through 16-volt battery, either online or offline. Before conducting any tests, it's important to take safety precautions required by the facility or your organization. Be sure to protect your eyes. Remove all jewelry, including wristwatches. Also, never forget that analyzers are not designed to test entire strings at once. Test individual batteries or jars only. We begin with a visual inspection. Look for evidence of battery problems, like post seal leaks, positive plate growth, fractures or ruptures around the post areas, and cracked or bulging cases. Also smell for hydrogen leakage, a rotten egg smell. All of these are indications of serious battery problems, and while you're at it, make sure the hardware is torqued properly. As part of your setup, be sure to test for temperature, which will affect conductance measurements. Scan the entire battery system, starting with jar 1 and working to the end, concentrating on the posts and connections. When you finish temperature testing, check the reading on your sensor. You will need to enter the average manually during the setup. The purpose of a conductance test is to diagnose whether or not the battery has a discharge performance problem. As a battery's performance declines, so does the battery's conductance. It's important to remember that voltage is only an indication of a battery's state of charge and not its performance capacity. Let's define a few terms. The basic value of conductance is expressed as Siemens or Mohs. We're looking for similarities in the battery measurements compared amongst themselves or against an established baseline measurement. The further away from that reference measurement, the more likely it is that the battery has a discharge performance problem. If so, the situation may require further investigation. The Celltron Advanced kit includes the microprocessor tester. It's highly programmable with preset reference values for over 250 battery types. It also has the ability to update as needed. It features enhanced internal memory. There are 16 memory registers, each capable of storing up to 480 test results in overall string statistics. It also interfaces with the PC for storage and data management. The Celltron Advanced kit, model CTA 4000, comes with several accessories, including 2 sets of testing probes and clamps, a digital infrared temperature sensor, an infrared-driven printer, a spare rechargeable battery, Inform software, and an infrared receiver, all contained in a protective hard plastic case. The infrared eye is located on the top of the unit and is used to communicate with the printer in a PC. This is the interface where you attach probes and clamps used during the testing. and this is the location of the fuse. The tester is protected to 20 volts. A recharger is included with the kit along with the spare rechargeable battery. Once you receive your tester, you can customize it to your requirements in the Utilities menu. Scroll up to Utilities. Here you can set language, date and time format, and edit string name. By string name, we mean a name that identifies the location. Incidentally, in some models of the Celltron Advanced, you may edit the string from the Set Parameters menu. But in this case, we'll just continue working out of the Options menu. Under the Select String display, scroll to the string you wish to edit and press Enter. Now you can scroll through the letters, symbols, and numbers for each character in the name you create. Press Enter after each character you select. When you're done with editing, press Enter and the unit will fill in the rest of the spaces. Returning to Utilities, we can now set percentages for warnings and failures. Scroll to the Warn Fail percent and press Enter. You can now scroll to select the string you want to set, or scroll to all strings. Scroll to each warn and fail percentage you want to set. Then press Enter after each selection. You can also edit the low voltage threshold. To do so, select the string name and press Enter. Now it's time to set parameters for this test. By setting parameters, we mean setting specific values for a string or location. In the Set Parameters menu, you can select measurements, volts only, or conductance and voltage. Select a test mode, auto start or manual start. Select test points, jars only or jars and straps. Set the string temperature. That is the ambient temperature reading we covered earlier in this presentation. Set the reference value. Set the number of volts per jar. Posts per jar. Select a particular jar. Add or edit vendor and model names. Let's talk about the most critical thing here, reference value. Reference values give you a baseline measurement to compare your results. To determine a reference value, you can consult your company records for values previously used. If you do not have reference values, there are a number of options. One is to test a sample of new or good jars and use this information as a baseline. You can also use the highest measurement of your sampling. Another option is to test the string and use the average from the string summary. Or you can utilize the database built into the analyzer to find the manufacturer and model of the jars you're testing. And if they can't be found there, you can contact the battery manufacturer or get an expanded list of the latest reference values at the Midtronics website. Your parameters are set and we have selected Auto Start. For convenience, you can clip the tester to your belt. The unit gives you an audio indication each time the test is complete. Let's start with the DuraProbes. The connector needs to be secured with the screws built into the unit. It's important to understand where the best contact points are. One contact point to avoid is the stainless steel hardware. Stainless steel gives lower test readings, possibly even a false failure indication. Instead, make sure the probe touches directly onto the lead post. This registers the highest measurement and the most uniform information. Rich is now performing a test. One thing to keep in mind is to be consistent. Utilize the same contact points each time. In 4 or 6 post batteries, the common practice is to take one measurement. But if you do it this way, be consistent. Select the same 2 posts each time on each jar. You can also set up the tester for 4, 6, or 8 posts and test each part individually. Now that the testing is completed, we can begin to interpret the data. We can view it 2 ways. You can print or view results which are located in the main menu. Using the printer included in the kit, we can print the summary and jar data. Line up the infrared eye of the unit with the infrared printer. From the Set Parameters menu, you can select Print Results. In a few seconds, the results are printed in the order tested. Let's take a close look at the readings for individual jars. we should look for jars with the lowest readings. Let's examine the lowest reading, jar number 5. It falls below the reference value we set for this test, so we should verify this by retesting. If you want to retest, simply press Retest. Another retesting option is to press Menu and press the retest key. Find the string and battery in question and press Retest again. Make sure you use the same contact points as in the original testing. The results of this test will replace the previous reading you had for this jar. Another testing option is to test both jars and straps. Rich is attaching the clamps and has selected jars and straps in the Set Parameters menu. Now he's going through the test routine, testing first the jar. On completion, we move one clamp to include both jar and strap, in this case jar 1 and the inner cell connection, or to jar 2. This measures the slight increase in resistance or loss in conductance through that strap. We continue on with jar 2. Test that jar, then again, including the strap. After we have tested both jars and straps, we can review that information. We expect to see a slightly higher measurement of the jar compared to the strap measurement. We expect the conductance measured to drop when we measure the strap. You can scroll through all your collected information to locate a pattern. The resistance or voltage drop in each of these battery measurements and strap measurements should be fairly even. Anything unusual indicates a potential problem with the strap. That completes basic testing information for string 1 at this particular site. It's important to document everything you test and leave a copy of it on site. And be sure to include information on which type of interface you have used, probes or clamps. Another way to archive test results is to utilize a PC for data storage. You can transfer reports, like the string test we conducted earlier, directly to a PC. Using the Inform software included in your kit, you can manage the data and generate reports in formats useful to you and your business. For further information on testing with the Celltron Analyzer, refer to your instruction manual and the quick reference guide. Determining whether a jar is good or needs to be replaced is not simple. Consult with the manufacturers where matters of warranties are concerned. Discuss your readings and observations with them before deciding a course of action. In general, we recommend following IEEE guidelines. Also consult guidelines set by the organization or company you're testing the battery for. As for the value of conductance testing, there is an understanding that a linear but not direct correlation exists. Also, as you test and compare the results with the history of the installation, look for trending. What is changing and how quickly are the changes happening? Ideally, battery strings should be examined regularly. Every 3 to 6 months is recommended. Recently installed cells should be examined as well. And we can't stress this enough. Make sure you're not comparing apples to oranges. Whatever parameters were set in the beginning, continue to follow them in each subsequent visit. The Celltron Advanced gives you a wide range of utilities and testing capabilities. Time doesn't permit us to go into each one in detail, but you can find information on their benefits and uses in the manual. And that is why the Celltron Advanced is called Advanced, the last word in battery management tools. We have just seen one of the dozens of tools developed here in the Midtronics Research and Development facilities. So many products, so much technology, so much effort, yet truly one focus: to carry battery management to new levels of accuracy, reliability, safety, and efficiency. Finding solutions for the power, communications, and data transmission industries is our mission at Midtronics.